Hello students, in today's class let us continue with the remaining problems in the exercise 16.3. Hope you have done the problems and you remember what are all the things we have learned in our previous classes. We have started learning about the axiomatic approach of probability and there are three axioms. What are those three axioms? The probability of any event lies in between 0 and 1 and it will be equal to 0 if it is of impossible event. It is equal to 1 if it is of sure event, and sum of the probabilities of all elementary events should be equal to 1, and for any event A, which is nothing but the probability, sum of the probability of each and every element of that event, right? And also we have seen probability of A union B is P of A plus P of B minus P of A intersection B, and P of A dash. A dash means complement of A, or we can tell it as not A, which is nothing but 1 minus P of A. If E and F are mutually exclusive events, then P of E union F is P of E plus P of F, right? These are all the various axioms involved in the probability. Based on all these things only, we have started solving the problems. We completed till question number 10 in our last class. Now let us see question number 11. See question number 11. In a lottery, a person chooses 6 different natural numbers at random from 1 to 20, and if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. So what is the probability of winning the prize in the game? Order of the numbers is not important, right? So they are going to choose 6 numbers from 1 to 20. So we should know how many chances are there to choose 6 numbers from 1 to 20. When we talk about chances, immediately what topic strikes your mind? Permutation and combination. Since the order of the numbers is not important, we are going to go for combination. So how many times? So what is the probability of an event? Probability of an event is number of favorable outcomes divided by total number of outcomes, right? So we need to know how many ways are there to choose 6 numbers out of 1 to 20, and how many ways are there to win. There is only one way. They have fixed the 6 numbers already, right? So that is our favorable outcome. Our favorable outcome is only one way of getting those 6 numbers which has been already fixed. So number of favorable outcomes is 1. Now we need to find what is the total number of outcome. What is total number of outcome? Out of 20 numbers, we have to choose 6 numbers. So how many ways are there? 20C6, right? Now how will you find the probability now? Total number of ways of choosing 6 numbers out of 20 is 20C6, which is nothing but 20 factorial divided by 6 factorial into 14 factorial. Why? What is the formula for NCR? The NCR is n factorial divided by r factorial into n minus r factorial, right? So 20 factorial divided by 6 factorial into 20 minus 6 factorial, which is 14 factorial, right? Therefore, probability of winning the prize is 1 divided by the total number of ways. You have to calculate this, right? Why it is 1? Because the number of favorable outcome is only 1. They have fixed that 6 number appear only, the person will win. So number of favorable outcome is 1. The total number of outcomes is 20C6, right? Hope you got it. Let us move on to the next problem now. Next question, check whether the following probabilities are consistently defined. They have given you P of A, P of B, P of A intersection B. With this, we need to check whether they are consistently defined or not. So how will you check whether they are consistently defined? We know that if E and F are 2 events such that E is a subset of F, then P of E is less than or equal to P of F. Probability of an event is less than or equal to probability of F, right? And we know the intersection should be always less than the individual probabilities, and union should be greater than the individual probabilities, right? Now if you look out this question, P of A 0.5 is less than 0.7. One probability is less than the other, but if you see the intersection, which is greater than the P of A. P of A intersection B is greater than P of A, and hence the first set of values are not consistently defined. Hope you got it. Intersection should be always less than the individual probabilities, right? But here intersection, probability of the intersection is greater than the individual probability. Therefore, the first one is not consistently defined. But if you check the second one, the union is greater than both the individual probabilities, and hence the second one is consistently defined. This is how only you have to check whether they have defined consistently or not, right? Let us see the next question. Fill in the blanks in the following table. They have given you P of A, P of B, P of A intersection B, and P of A union B. Now, what is the relation between all these things? We have learnt through the axiom of probability. What is that? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, right? Now, there are 4 values involved in this axiom. Out of these 4, they have given you 3 in each subdivision. So, if you see in the first subdivision, P of A, P of B, P of A intersection B is given. So, if you substitute in this axiom, we can find what is P of A union B. In the second subdivision, P of A intersection B, A union B is given. They didn't give P of B. So, bring all the known numbers to the other side, we can find what is P of B. The same way you can do the third subdivision. So, I am leaving this question to you. We are moving on to the 14th one. Given P of A equal to 3 by 5, P of B equal to 1 by 5, find P of A R B. What is meant by A R B? A R B means A union B. A and B means A intersection B. Remember, we have learnt in the chapter sets and even in the introduction of probability as well. So remember. So they have given you P of A value, P of B value. They asked you to find P of A union B. If A and B are mutually exclusive. If A and B are mutually exclusive, then A intersection B is empty, right? So if A and B are mutually exclusive, what is P of A union B? Which is nothing but P of A plus P of B. So it is enough if you just add and give the answer, right? Now 15th question. If E and F are even such that P of E, P of F, P of E and F. E and F means E intersection F. They have given you probability of E intersection F is 1 by 8. Find P of E R F. The same way. They asked you to find probability of E union F. E union F is nothing but P of E plus P of F minus P of E intersection F. Substitute all the values and find the answer. See the second subdivision, P of not E and not F. Not E means what? E complement. Not F means what? EF complement. And means what? Intersection. So this is nothing but probability of E dash intersection F dash, right? Which is nothing but probability of E dash intersection F dash. Hope you remember De Morgan's law, which we have learnt in our 6th chapter. So what is P of E dash intersection F dash, which is nothing but probability of E union F the whole dash. Hope you remember E dash intersection F dash is nothing but E union F the whole dash. So this can be written as E union F the whole dash. But what is P of A dash? P of A dash is nothing but 1 minus P of A, right? Now our A is E union F. So P of E union F the whole dash. Only when you have whole dash it can be considered as the single set, right? Here you should not write P of 1 minus P of E intersection 1 minus P of F. That you cannot split. So here it can be written as 1 minus P of E union F. Now you know what is E union F. You would have found it in the first subdivision. That value if you write and subtract from 1, you will get the answer for this. Yes. So what is probability of E dash intersection F dash, which is nothing but probability of E union F the whole dash. E union F the whole dash. It can be written as 1 minus probability of E union F. Right? Hope you understood. Let us move on to the next question now. 16th question, events E and F are such that P of not E or not F is equal to 0.25. State whether E and F are mutually exclusive. They asked you to check whether E and F are mutually exclusive. If two sets are mutually exclusive, then their intersection should be empty. Only if the intersection is empty, the two sets are called as mutually exclusive, right? So how can we solve this? P of not E or not F, which means what? E dash union F dash. Probability of E dash union F dash is equal to 0.25. So how will you solve this problem? Probability of E dash union F dash. Again here we are applying De Morgan's law. E dash union F dash can be written as E intersection F the whole dash, right? E intersection F the whole dash. Again here it is a complement, so 1 minus P of E intersection F, and this value is given as 0.25. This is given as 0.25. Now we need to know what is P of E intersection F. So bring this to the other side and bring this number to the other side. So if you subtract from 1 0.25, we will get 0.75, which is not equal to 0. Therefore E and F are not mutually exclusive events. If they are mutually exclusive events, their intersection should be empty, right? And their probability also should be empty. But here we are having non-zero value. Therefore E and F are not mutually exclusive events. This is how only you have to conclude the problem. Yes. See the 17th question now. A and B are even such that P of A, P of B, P of A and B means A intersection B is given. They asked you to determine P of not A, not B and A or B. Hope you can do this problem by your own. A not A means A dash. P of A dash is 1 minus P of A. Not B means B dash. B dash is 1 minus P of B. A or B. P of A union B is P of A plus P of B minus P of A intersection B. Yes, you can do. All the values are given. Let us move on to the next question. In class 11 of a school, 40% of the students study mathematics and 30% students study biology. 10% of the class study both mathematics and biology. If a student is selected at random from the class, find the probability that he will be studying mathematics or biology. So what is given here? 40% of the students study mathematics, means 40 out of 100. So probability of studying mathematics is 0.4, right? Similarly 30, because what is the probability of an even formula? Favorable outcomes divided by total number of outcomes. Number of students studying mathematics is 40, total number of students is 100. How do you know that? Because they have given in percentage. So likewise you can calculate probability of students studying bio is 0.3. Probability of students studying both mathematics and bio, which means M intersection B, which is 0.1. So they asked you to find probability of M union B. Again you have to substitute in the formula. Yes, these are all very easy problems. You can do it by your own. 19th question is also in the same way. In an entrance test that is graded on the basis of 2 examinations, they have given you the probabilities directly, but instead of giving you like this, they have given you in a statement problem. You have to understand and find out which they are talking about, and you have to use the axiom. The probability of passing at least one means union is given. They asked you to find passing both. Intersection they asked you to find out. Union is given, individual probabilities is given. They asked you to find out intersection, right? 20th question, the probability that a student will pass the final examination in both English and Hindi. Both English and Hindi means intersection is given. Probability of passing neither means not Hindi, not English. So which means probability of E dash intersection H dash, which is given as 0.1. If the probability of passing the English examination is 0.75, probability of passing the English examination is 0.75, probability of E is 0.75. What is the probability of passing the Hindi examination? They asked you to find P of H. See, probability of E intersection H is given, not E and not H, the same way as we have done in the previous problems. Probability of E union H to the whole dash, which is nothing but 1 minus P of E union H. So we can find what is P of E union H. So we got what is P of E union H, E intersection H, P of E. So we can very well find what is probability of H, right? Last question in the exercise. In a class of 60 students, 30 opted for NCC, 32 opted for NSS and 24 opted for both NCC and NSS. If one of these students is selected at random, find the probability that the student opted for NCC or NSS. So if you can take NCC as A and NSS as B. So total number of students is 60. A number of students who opted for NCC is 30. This N of B is 32 and 20 opted for both, which means intersection. These are all not probabilities, the number of students. So understand the question, don't blindly give your answer. Whether they have given you the probability directly or they have given you the number of students, you understand it. Okay, in this question, they didn't give you the probability directly. They have given you the number of students and they asked you to find the probability. So you have to find what is probability of A, probability of B. Then only you can proceed with the problem. Alright. Number of students who opted for both NCC and NSS, which means N of A intersection B is 24. If one of these students is selected at random, find the probability that the student opted for NCC or NSS. So they asked you to find probability of A union B. Alright. Now how will you solve this problem? As I told you, first you have to find the probability of each event. P of A is N of A divided by N of S. So 30 divided by 60, which is nothing but 1 by 2. Similarly, probability of B is N of B divided by N of S. So 32 divided by 60. Same way intersection. So we found all the probabilities. Now your first question is P of A union B, which can be directly found by using the axiom. P of A plus P of B minus P of A intersection B. Alright. Second subdivision is the student has opted neither NCC nor NSS, which means A dash intersection B dash, neither, rendume illa, right? So A dash intersection B dash, so which can be written as probability of A union B the whole dash, which is nothing but 1 minus P of A union B. Now we would have found A union B in the first subdivision. You can use that value and give the answer for this. Third subdivision is the student has opted NSS but not NCC. The student has opted NSS but not NCC, which means we have taken NSS as B, NCC as A. See, NCC as A, NSS as B. So they have given you opted NSS but not NCC. So not means A complement. P of A complement intersection B. So what is this? We have to find out what is N of A dash intersection B first. Which is A dash intersection B? A dash intersection B is nothing but N of B minus intersection. Why? Because the student has opted only NSS. NSS is only this. This is only NSS. Right? This region is only NSS. We need to know only this. How will you find this? Full B minus this intersection part. So N of B minus N of A intersection B. N of B is 32 minus N of A intersection B is 24. So if you subtract, we got 8. Therefore, probability of this is 8 divided by 60. Right? So like this only you have to give the answer for this kind of problems. So with this, let us wind up today's class. And I want you to complete question number 11 to 21. Do question number 11 to 21 as homework from exercise. Do question number 11 to 21 from exercise 16.3 as homework. And if you have any doubts, you can ask me. With this, let us wind up today's class. Thank you, students.